All right, let's talk about 2.3, which is a pretty short section just about how to use your calculator to approximate trig function values. So let's get started. Let's approximate the value of each expression, and we'll start with sine of 49 degrees 12 minutes. Now, if you have a calculator that has a degrees and minutes button, then you can just do this directly on your calculator. So in my case, I can do, for example, sine of 49 degrees 12 minutes, and that gives me approximately 0.756995. I didn't say how much to round to, so we'll go maybe 4 decimal places, I guess. So if we go 4 decimal places, what would this be? So 0.7570, I suppose, right? Another thing you could do, though, if your calculator doesn't have minutes on it, is that, of course, you could change this into decimal degrees, right? So you could say 49 degrees 12 minutes is equal to 49 degrees and 12 sixtieths of a degree. So I guess I could put a little plus sign there. And then you could pop that into your calculator. Of course, you could reduce it as well, right? Like 12 out of 60 is 1/5. So, so you could call this 49 and 1/5 of a degree, something like that. And then just pop that into your calculator. And say, you know, sine of 49 and 1/5 degree. But you should get the same. You should get the same answer if you do it that way. So if you have a minute button, then you can just put it in directly. Otherwise, you know, change it into degrees. Change it into a fraction of a degree, or if you wanted, you could even change it into a decimal, I suppose. Let me show you another one. So let's say that you wanted to do secant of 97.977 degrees. Now, most calculators don't have a secant button on them. So what you have to do is use a reciprocal identity, right? So you have to say, well, secant is just 1 over cosine. So secant of 99.977 degrees should be the same as 1 over cosine of 97.977 degrees. And then this you can plug into your calculator, because your calculator should have a cosine button on it. So let's see about how much that is. So 1 over cosine of 97.977. That's about negative 7. If we're going 4 decimal places, negative 7.2059. Okay. Here's another one. We'll do 1 over cotangent of 51.4283 degrees. Okay. Once again, this is another example of one that you don't have a cotangent button for, but you do probably have a tangent button, so you should just use a reciprocal identity. 1 over cotangent is the same thing as tangent, right? So this is just tangent of 51.4283 degrees, and you can use your calculator for that. So 1.2540. And one more for good measure. So sine of negative 246 degrees. Just to make sure you can enter negative values as well. Negative 246 is about 0.9135. Okay. So that's that. Let's do something a little bit different. So let's find an angle theta in the interval 0 to 90 degrees that satisfies the given condition. Let's do this for sine theta equals 0.325. So here we have to work backwards a little bit. It's like we're thinking about an angle theta such that sine of that angle is 0.325. So you wouldn't punch into your calculator sine of 0.325. What you would punch into your calculator is a sine inverse button, right? So you would say, well, if this is the case, then theta equals sine inverse of 0.325. So what you really want to put in other words, maybe I can make it more explicit. What I'm saying is if you want to solve for theta, then the thing that undoes sine is sine inverse. It's not true that you can just divide both sides by sine. That doesn't even make any sense. I'm saying that because a lot of students will do that. It's not correct. You want to take sine inverse of both sides. That's how you get rid of sine, is by taking sine inverse. Anyway, so in your calculator, you're going to say you have to find the sine inverse button, okay, but it's a little different. It has that little -1. So you're going to do sine inverse of 0.325. And you get 18.9656 degrees. Okay. So let me give you one to work on. See if you can figure out theta if tangent theta is equal to 3.4. So go ahead and give the video a pause, see if you can get that. Okay, so here's what you should have. You should say theta equals tangent inverse of 3.4, and then use your calculator to do tangent inverse of 3.4. So that's 73.6105. degrees. Okay. Let's do another one. Let's do secant theta. Hold on a second. All right. Sorry, I have to take a phone call. Anyway, so let's do this for secant theta equals 1.0546. Now, with this one, you don't have a secant inverse button, right? So it's like our first kind of naive approach would be to say, well, theta is going to be secant inverse of 1.0546. But that's a problem because you don't have a secant inverse button. So then what you might be tempted to do is to say, well, secant is 1 over cosine, right? So isn't this just 1 over cosine inverse of 1.0546? And the answer is no. It's a little different than that. So that's not going to work out. This is not correct. Okay? It is true that secant is 1 over cosine, but secant inverse is not 1 over cosine inverse. So here's what you do. Here's what you should do. So from the very beginning, you should say since secant theta is 1.0546, that means that cosine theta is 1 over 1.0546. And now you can take cosine inverse, right? Now you can say theta should be cosine inverse of 1 over 1.0546. So the difference between this and this is pretty subtle, but notice the placement of the cosine inverse, right? Here, you're taking cosine inverse of 1 over the original value. Here you have 1 over cosine inverse of the original value. So and they do give you different answers. This one is not correct. This one is. Okay? So just remember, secant inverse is not the same thing as 1 over cosine inverse. But secant is the same thing as 1 over cosine. So you have to switch, you have to use the reciprocal identity before you take the inverse. Okay, so use the reciprocal identity first, then take the inverse. Okay, let's see what we get. So you should have cosine inverse of 1 over 1.0546. So that's about 18.5175 degrees. Okay, so make sure that you can get these values, right? So that you know how to use your calculator correctly. I'll give you one more kind of like that for you to try out on your own. So try out cotangent theta equals 3.4. You did tangent theta equals 3.4 a second ago. See if you can do cotangent theta equals 3.4. Okay, so here's the trick. You're going to say if cotangent theta is 3.4, then tangent theta is 1 over 3.4, and therefore theta is tangent inverse of 1 over 3.4. About 16.3895 degrees. Okay. So that's that. Let's do another kind of problem. Okay, so this time let's try to find two angles that satisfy the given condition. Let's do sine theta equals 0.5299. Let's see if we can find two angles that satisfy that condition. Okay. Well, one angle that's going to satisfy the condition is, of course, just sine inverse of that original number. So let's see, sine inverse of 0.5299 is about 31.9987 degrees. Okay, so there's one possibility. Another possibility is that so the sine function it just repeats, right? It's periodic. So another angle that would satisfy this condition, it would be tempting to just add 360 because you know that coterminal angles are going to have the same sine, cosine, tangent, whatever. But our angle has to live in the interval from 0 to 360. So what do? Well, as we've discussed, sine is positive in quadrant 1 and in quadrant 2. So the other angle, this angle that we got was the angle in quadrant 1 that satisfied this condition. The other one should be in quadrant 2, right? So how do we get into quadrant 2? We need the angle to have the same reference angle as what we have here. So we need, so there's one, maybe I'll call it theta 1. So there's one angle. But then the other angle, there should be another one here in quadrant 2, theta 2, whose reference angle is theta 1, right? So what is that going to be? That's going to be 180 degrees minus theta 1, right? So theta 2 should be 180 degrees minus theta 1. Okay, so that's 180 degrees minus 31.9987. So you should get that that's about 148.0013 degrees. Okay, so that's how we do this kind of thing. Let me give you one to work on. So see if you can do this for cosine theta equals 0.1045, and I'll warn you that for the second angle you're not going to do 180 degrees minus theta 1. You need to think about where cosine is positive. Okay, so go ahead and give the video a pause, see if you can try that out. Okay, so here's my solution. Obviously theta 1 is going to be cosine inverse of 0.1045. Theta 2, well, cosine is positive in quadrant 1, but it's also positive in quadrant 4. And so if this is theta 1 and this is theta 2, we need theta 2 to have the same reference angle, so we need this to be theta 1 as well. So the question is, how do we describe theta 2? Well, it's going to be 360 degrees minus theta 1. Okay, that's how we're going to find it. Let's see what we get. Oops. Cosine inverse of 0.1045 is about 84.0016 degrees. And then 360 degrees minus that is about 275.9984 degrees. Okay. One more for good measure. Let's do tangent theta equals 0.7. So go ahead and give the video a pause, see if you can do that one. Okay, here I go. So obviously, theta 1 is going to be tangent inverse of 0.7. Theta 2, on the other hand, let's see how we would describe theta 2. Tangent is positive in quadrant 1 and in quadrant 3. We need the reference angle to be theta 1. So the question is, how do we describe theta 2? Well, it would be 180 degrees plus theta 1, right? Let's see what we get. Tangent inverse of 0.7 is about 34.9920 degrees. And then that plus 180 is about 214.9920 degrees. Okay? And that's that. One last problem. So I want to show you kind of an application problem. So example 4. I'm not writing all of this down again, but you're welcome to pause the video and kind of write it down if you would like to. Anyway, it says the grade resistance F that an automobile experiences while traveling uphill or downhill is modeled by F equals W sine theta, where W is the weight of the automobile and theta is the grade. Okay? And just by convention, we take theta to be a positive angle if we're traveling uphill and theta to be a negative angle if we're traveling downhill. Here I used traveling with one L, and here I used traveling with two L's. I think it's one of those words that actually legitimately both spellings are correct. I could be wrong. Doesn't really matter. And then I'm back to one L down here. Who knows? Okay. But anyway, so let's calculate the force, or the grade resistance, I suppose. Let's calculate the grade resistance for a for a 2,500 pound car traveling an uphill grade of 2.5 degrees. Okay, so let's do it. Right, so for part A, F equals W sine theta, where W is the weight. So the weight is 2,500 pounds in this case, and the grade is 2.5 degrees. So we just pop that into our calculator. 2,500 times sine of 2.5 degrees. It didn't say how much to round to, so I'll say this is approximately 109.05, I guess. Okay, so there's part A. Part B, it asks us, calculate the grade resistance for a 5,000 pound truck traveling a downhill grade with theta equals negative 6.1 degrees. Okay. So again, this time we've got a 5,000 pound truck, and we're going downhill. The grade is negative 6.1 degrees. What do we get? 5,000 sine of negative 6.1 is about negative 531.32. Okay, and then the last one. Part C asks us to calculate the grade resistance for theta equals 0 degrees and theta equals 90 degrees. Do the answers agree with your intuition? And notice that we're not even given the weight of the automobile here. Well, so let's see. It must be because it doesn't really matter, right? Let's see. So for theta equals 90 degrees, this would mean that you're climbing straight up, right? You're climbing straight up. And so you would get F equals W times sine of 90 degrees. We don't know what W is. They didn't give it to us. But sine of 90 degrees is 1, right? So you just get F equals W. In other words, the grade resistance is whatever the weight of the automobile is. And that does make perfect sense, right? That makes total sense. Because if you're trying to drive straight up, like literally you're trying to go up a vertical wall or something, then you're going to have to fight against the entire weight of the vehicle. So that makes total sense. What about for theta equals 0 degrees? Well, sine of 0 degrees is 0. And W times 0, whatever W is, anything times 0 is 0. So the grade resistance for a 0 degree incline would be 0. Which again, makes perfect sense because you're not even on a grade, right? So there's not going to be any grade resistance. So that's that. That'll do it for 2.3. We'll see you in the next one.